Hello students, good morning to all of you. So आज का हमारा टॉपिक है रॉकेट propulsion and I'm going to explain rocket propulsion on the basis of law of conservation of linear momentum. As a rocket, inside a rocket there is a combustion chamber where we have the fuel and oxidizer. So all the chemical reaction takes place inside the rocket, inside the combustion chamber. So there are no external forces involved as I am taking this rocket as a system. So there are no external forces on the system, so its momentum remains conserved. So इस केस में हम क्या करेंगे, डिफरेंट टाइम्स पे रॉकेट का मोमेंटम कैलकुलेट करेंगे, उसकी जर्नी के दौरान उसका मोमेंटम कैलकुलेट करेंगे एंड देन अप्लाई द लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम. So let us suppose the mass of initial mass of a rocket plus fuel is like m naught initial. Okay, so now we take some two situations and some different instants of time and write the expression for the momentum of the rocket. Let us suppose at any time t, rocket has a mass m and it has a velocity v. Okay, at some instant at time t, rocket has a mass m and it has a velocity v, and just after a very short interval of time like t plus dt, it has a mass m minus dm and velocity v plus dv. There is a change in the mass, there is a loss in the mass, because after that t plus dt, means after that dt time, some of the fuel is burnt inside the chamber. Okay, some of the fuel is burnt inside the chamber and the gases will eject out in the backward direction. Gases will eject out in the backward direction with some velocity vg. This velocity vg is the velocity of ejected gases with respect to observer that is on the ground. Okay, this is the velocity of ejected gases with respect to the ground. These are not respect to the rocket. उसको हम बाद में इस एक्सप्रेशन में इनकॉर्पोरेट करेंगे, बट दिस इज द वेलोसिटी ऑफ द इजेक्टेड गैसेस दैट इज रिप्रेजेंटेड बाय Vg. एंड लाइक सो यहाँ पर कुछ मास जो है, मास हैज बीन बर्न्ट आउट, फ्यूल हैज बीन बर्न्ट आउट, सो कुछ मास रिड्यूस हुआ है. नाउ उसी वजह से जो नया मास है वो m माइनस dm हो गया है, वेलोसिटी v प्लस dv हो गई है, बट साथ ही साथ में यहाँ पर कुछ गैसेस इजेक्ट हुआ है Vg वेलोसिटी के साथ, एंड दैट इजेक्शन कैरी आउट दैट मास dm. ओके, that is responsible for that mass dm. Okay, so now we have two conditions at time t plus dt. So now I'm going to write the expression for conservation of linear momentum, because the momentum in this situation should be equal to the momentum at this time interval. Okay, at this time. So here at time t, the momentum of rocket is mass into velocity, and now at t plus dt, the momentum of rocket is m minus dm multiplied by v plus dv plus vg into dm. Vg is the velocity of ejected gases. Okay, as if rocket is going in the upward direction, if we take the upward direction as the positive direction, so downward direction is being taken as the negative direction. So Vg का जो sign है वो negative आ जाएगा. Okay, so now we just solve this equation mv is equal to this equation. I am just writing this equation here now. इसको solve करने के बाद हमारे पास upthrust के लिए और different expressions आएंगे. Just look into that. So equation is now mv is equal to m into v and m dv, and after that it is minus dmv minus dm dv. Just multiply किया है and minus Vg dm. Vg का मतलब है velocity of ejected gases. Okay, तो ये mv से mv कैंसिल हो जाएगा, and we have some other things like ये जो dm into dv है, these are the small values. So product of small values is also very small. So we will neglect this expression, this thing from this expression हम यहाँ से neglect कर देंगे. So we are just left with m dv is equal to, इनको इस तरफ ले आइए तो they will get the positive sign, तो आ जाएगा dm into v plus vg dm, and then we take the dm common, we have v plus vg and expression in this side is m dv. इस तरह का कुछ expression हमारे पास आ जाएगा. We just use that, note that equation and name it as equation number 1. Now we introduce the concept of relative velocity here. Okay, ये बहुत important step है. First of all, we give that कि ये जो v है, this is the velocity of rocket at time t, and ये जो vg है, this is the velocity of rocket, velocity of gases, this is the velocity of gases that is ejected out. तो v represent कर रहा है rocket की velocity, v gases represent कर रहा है velocity of gases ejected out. Okay, now I want to calculate, I want to know about the expression of relative velocity of gases with respect to the rocket. ये जो v gases है, ये gases का velocity है with respect to the observer that is on the ground. Okay, but I want the velocity of gases with respect to the rocket, कि किस velocity से वो उनको exhaust कर रहा है. What is the velocity of gases with respect to the rocket, वो निकालना है. तो I represent that with u. जनरली बुक्स में u से रिप्रेजेंट किया जाता है. u इज द रिलेटिव वेलोसिटी ऑफ गैसेस विद रिस्पेक्ट टू द रॉकेट. और रॉकेट की v से रिप्रेजेंट कर रहे हैं, गैसेस का v गैस से रिप्रेजेंट कर रहे हैं, और u इज द रिलेटिव वेलोसिटी. बट नाउ जो v गैस है, इट इज इन द डाउनवर्ड डायरेक्शन, सो आई पुट इट साइन हियर, वेरी सिंपल वे, एंड दिस इज माइनस v इज इक्वल टू u. सो वी कैन राइट दिस एज माइनस vg प्लस v इज इक्वल टू u. So what is the value of Vg plus V? Vg plus V का वैल्यू आ जाएगा minus of U. We just note it as equation number second. So we just use that equation number second in equation number 1. So we have the expression as m dV is equal to dm into minus of U. Okay, this is our third equation and this is one of the most important equation जिसका हम आगे इस्तेमाल करने वाले हैं. Just 1 minute. So now you just see that this is m. We divide both sides by dt. हमने यहाँ dt से divide किया and it is like minus u dm by dt. dm by dt means rate of change of mass with respect to the time. So dv by dt का मतलब है s relation. So मैं इसे काट नहीं रहा हूँ basically. dv by dt is like s relation. So it is ma and ये बनेगा minus u dm by dt. ma means force according to the second law. So minus u dm by dt. So I have the expression for the force, and this force is known as the upthrust. This force is known as the upthrust on the rocket. This is the upthrust on the rocket, and this is in the upward direction. So at last we just reach at the expression for the upthrust. This is F is equal to minus u dm by dt, and this is the upthrust. This is in the upward direction. Okay, इस तरह से आप upthrust के लिए expression निकाल सकते हैं. dm by dt is representing rate of change of mass with respect to time. And u means relative velocity of gases with respect to the rocket. कि मतलब rocket किस velocity के साथ, like what is the exhaust velocity of the gases with respect to the rocket, इसका मतलब है minus u. Okay, so ये हो गया force के लिए expression, upthrust के लिए expression. Now we can also derive an expression for, मैं इसे यहाँ note कर लेता हूँ, F is equal to minus u dm upon dt. Okay, this is the expression for upthrust on a rocket. Now I can also derive expression for the velocity. What is the velocity at any instant? I can derive the expression for that velocity. So हमारे पास एक expression यहाँ पर आया है. This is like m dv dm v plus vg. और एक और expression हमने इसको थोड़ा और simplify जब किया था, तो वो था m dv is equal to minus u dm. Okay, this was the expression. ये भी हमने यहीं से derive किया है. We want the velocity. Okay, so we just write it as dv is equal to minus u dm by m. Okay, m मैं नीचे लेके आया, dv is equal to minus u dm by m. So let us suppose we have some velocity as initial right at v naught, and we want the velocity v, and here we just use the conditions of mass within the proper limits, like m naught is the initial mass and m is the some mass when we want the velocity. कि मतलब इस एक्सप्रेशन से हम ये जानना चाहते हैं कि जब हमारे रॉकेट का मास m है, m is the mass of the rocket, उस टाइम पे क्या वेलोसिटी उसका है, तो यहाँ से हम फाइंड आउट कर लेंगे. सो वी जस्ट इंटीग्रेट dv, इसका वैल्यू आएगा v, एंड लिमिट्स आर लाइक v नॉट टू v. ओके, एंड माइनस u बाहर ले लीजिए, ये dm by m का इंटीग्रेशन आएगा. log e m limits are like m naught to m. So I'm just writing this expression here. So ये आ जाएगा v minus v naught upper limit minus lower limit is equal to minus u log e m minus log m naught. ओके, ये एक्सप्रेशन मैं अब थोड़ा यहाँ लिख रहा हूँ, इसकी हमें जरूरत नहीं है. सो जस्ट अ मिनट. सो वी आर गेटिंग दिस एक्सप्रेशन एज v minus v naught is equal to minus u log a minus v I can write as log a upon v. So log e m upon m naught. Okay, so v is what? V is like v naught. मैं इसको प्लस कर सकता हूँ u log e m naught को ऊपर ले जाना पड़ेगा, m naught upon m. Okay, so these both are the expressions. Like this is some equation number 1 dash, this is equation number 1 double dash. Okay, so ये दोनों equations हमें velocity का expression देते हैं. हम यहाँ से velocity find out कर सकते हैं. This is very easy to calculate the velocity. This is the velocity v of the rocket when its mass is small m. उस टाइम पे क्या velocity है, you can calculate this. If your initial velocity is like 0, so you will put in place of v naught as 0, so expression will come v is equal to u log e m naught by m. एक और यहाँ पर जो पूछा जाता है वो है burst out speed of the rocket. The burst out speed का मतलब क्या है, या burnt out speed of the rocket. ये वो speed है like when most of the fuel get exhausted, when entire fuel get exhausted of your rocket, उस टाइम पे जो आपके रॉकेट की स्पीड होगी उसे burnt out speed of rocket या burst out speed of rocket कहा जाता है. तो उसका एक्सप्रेशन होगा v burst, यहाँ इसके साथ सबस्क्रिप्ट में b लगा देंगे, इट इज इक्वल टू u log e m naught upon mr. सो mr का मतलब है रेजिड्यूल मास. mr का मतलब है रेजिड्यूल mass of the rocket. Means your fuel get exhausted, you are only left with the mass of the rocket. तो इस एक्सप्रेशन की हेल्प से आप burnt out speed भी कैलकुलेट कर सकते हैं. This is the upthrust on the rocket minus u dm by dt, and this u is the relative velocity of gases with respect to the rocket, and this is like your dm by dt, rate of change of mass with respect to time. So this is a varying mass problem. Okay, mass is being varied in this process, and v is u log e m naught by m. इस एक्सप्रेशन का यूज करके कि m मास जब है उस समय पे क्या वेलोसिटी है आप फाइंड आउट कर सकते हैं. सो आई होप you have understood the basic process in the propulsion of a rocket, because in this rocket propulsion we have a combustion chamber inside the rocket where oxidizer and that fuel is being mixed, and oxidizer helps in the burning of the fuel. So there is no external force involved in this case. All the momentum remains conserved, as we know that if on a system there is no external force, that its momentum remains conserved. So we just take the momentum of this rocket at various situations. Like t पे हमने उसका mass velocity mv लिखा, t plus delta t पे हमने उसका देखा mass reduce हुआ है, m minus dm हुआ है, एंड उसका वेलोसिटी जो है वो v प्लस dv हुआ है. एंड साथ ही साथ में कुछ मोमेंटम जो इम्पार्ट हुआ है डाउनवर्ड डायरेक्शन में गैसेस के साथ, वो भी हमने अकाउंट में लिया और कंजर्वेशन का इक्वेशन लगाया और इक्वेट किया, एंड वी जस्ट गेट द एक्सप्रेशन फॉर द फोर्स बाय डूइंग सम लिटिल मैथमेटिक्स हियर, and after that we derived an expression for the velocity. I hope you have understood the entire derivation or concept of this rocket propulsion. With that, thank you very much.